Hi, my name is Bahadur Ahmedov. Welcome to the course of Probability and Statistics. From this lecture, we're going to start learning about the rules of probability, such as additional, multiplication, and the conditional probability. We are going to start learning from the additional rule, or basically OR rule, which basically tells us that, hey, if you have a sample space, what you need to do is, so you're having the sample space, you're going to define some event inside the sample space, A, let's say. And we previously considered the definition of the probability of this A, where we are just finding the size of this A and dividing this to the size of the omega. So now, inside this sample space, so let's say we have another set B. Now what I want is, I would like to find the probability of A or B. Right? And what does it mean in this case? If you choose one item which is from the A, it is also success. And if you choose one item, if it is from B, it's also success. A or B. If A happens, but B doesn't happen, it's still success. If B happens, but A doesn't happen, it's still success. So from the perspective of the zeros and ones, basically it's going to be, if A is 0 and B is 1, it is going to be 1. If A is 1 and B is 0, it's also going to be equal to 1. So either of this one of the events should happen in order to this event will happen. So obviously it is going to be so probability of A or B should be bigger than the probability of A and the probability of the B separately. So that is why it is logical to add the probability of the A and the probability of the B together in order to find the probability of the A or B. So let's consider an example. So let's say you are going to roll a die. Our experiment is going to be a roll a die. So the 6-sided cube. So this is going to be our sample space, and it contains 6 outputs. 1, 2, 3, 4, 5, 6. So now let's assume that A is going to be an event which is going to contain the 3 items like 1, 2, and 3. And the B is going to be an event which is going to contain only 1 item, 4, for example. So let's play a game. Like if you roll a die, and if you get one of the items from the A, like 1, 2, or 3, you're going to win. Then find the probability that you're going to win. So in order to do this, we need to find the probability of the A. So it is going to be 3 divided to the 6, or 1 over 2. So at the same time, let's play another game. If you roll a die and if you get the result which is from the set B, or basically 4, you are going to win in this game. It's going to be a probability. So let's find the probability that you are going to win this game. It's going to be 1 over 6. So now, I would like to play a new game where I say, hey, you roll a die. If you get a result from the A or from the B, you are going to win. So either you need to get the results from the A, but if you don't get the result from the A, but at the same time you get the result from the B, you still are going to win this game. So basically, probability of the A or B is going to be equal to probability of the A plus the probability of the B. So it is going to be equal to the 3 over 6 plus 1 over 6. It's going to be equal to the 4 over 6 or 2 over 3. So this is called the additional rule, but there are some problems here. So when we are considering the additional rule where we just adding the probabilities of the A and the B, we are assuming that these two events are disjoint. Basically, they are not intersecting. So if the probability, so if you look to this A as one set, B should not have any intersection points as here, right? So the A has 3 items and B have here 4 just 1 item, but they are not intersecting between each other. So we call this kind of events where they cannot happen at the same time, or they are not have any intersections, as the mutually exclusive events. So for the mutually exclusive events, probability of the A and B, so probability that they are going to happen together, basically probability that they happen together at the same time so let me delete this part, is equal to the 0. So in this case, we say that they are mutually exclusive. For example, the example of the mutually exclusive is again this set. So let's say if you roll a die, if you get results 1 and 2, you are going to, so the A event is going to happen. If you get results 3 and 4, B is going to happen. So are these two events are mutually exclusive? Yes, because they cannot happen at the same time, right? So if you roll a die, either A might happen, either B might happen, either neither of them might happen, right? So in this case, we say that they are mutually exclusive. So, but at the same time, there are problems or there are sets which are not mutually exclusive. So I can give you an example from here even, right? So even from rolling a die. So let's start with the rolling a die one more time. So we have a set of A which is going to contain the numbers 1, 2, 3, 4. And we have a set B which is going to contain the numbers 4, 5, and 6. So is it possible that these two events are going to happen together? Yes, because we have one item which is included in both of the cases, right? So they have the intersection points. So probability of the A and B is not equal to 0 anymore. So whenever you would like to find the probability of the A or B, now you can just you cannot just add this probabilities. So if you remember what we did before, we found the probability of the A and added the probability of the B. So if you find the probability of the A, it's going to be 4 items in the 6 divided to the 6, which is the size of the sample space. And the probability of the B is going to be 3 items in the B divided to the size of the sample space, which is 6. But the problem is you are including this 4 twice here, right? So you're including this 4 here. At the same time, you're including the same 4 to here. So basically, you're including the 4 2 times. So that is why you need to subtract 1 time the 4, which you have included twice. So that is why we need to subtract this probability of the A and B. So basically, probability of the A and B from the set's perspective is the intersection of the two sets. So find intersection of the two sets basically mean the items which are included in both of the events, right? So in this case, it's going to be just 4, and the probability of this, it's going to be, so 1, because only one item is included in both of the events, divided to the 6. Okay, so probability of the A and B is going to be equal to 1 over 6, and we have to subtract this from a probability of the A plus the probability of the B. So the answer is going to be equal to simply 1, right? So so this is the additional rule in the general form. Probability of the A or B is going to be equal to the probability of the A plus the probability of the B minus probability of the A and B. So in this case, probability of the A and B means intersection of A and B. So when we're looking to the sets and to the Venn diagram, so this is going to be A, for example. So let's say this is the B. So they have some intersection, right? So this is the intersection, A and B. So basically you need to subtract this. So what you're going to do is you're going to add all the terms from the A, then all the terms from the B, then you're going to subtract their intersections, because actually when you're adding all the terms from the A and all the terms from the B, you're adding this intersection section twice. So you need to subtract one of them. So this is the additional rule.